Hello, everyone. This is Ron Gerber from AngelBeat. It's 1 o'clock East Coast time. I'm so glad that all of you are spending time out of your busy days to join myself along with Brian from AWS and Raphael from Trend Micro. I know as I go around the country that there is tremendous interest in cloud computing and security. Those are the two major issues that organizations, individuals are dealing with around the country. And so what I wanted to do in pulling together this webinar, we've got these two great experts to talk in broad strokes about cloud strategy. Brian can touch on things such as the shared security responsibility model that organizations have to understand in terms of what AWS does, what experts like Trend Micro do, and what individuals have to do for their own organization securing that data. And the other big theme beyond cloud and cloud security is what's going on with your application security as organizations are migrating to the cloud. How does all that work? So without any further ado, we're going to start this off. We're going to start with Brian. I just want to point out to everyone, I'll be monitoring the question and answer, the chat button. Zoom has a number of good support functions, so you could always contact me via the chat window. Just as an FYI, my cell phone is 212-879-6808, so people can text me or call me on that, or else email me at rgerber@angelbeat.com to make sure that all of you have complete and easy access to this wonderful content. We'll also make this available for downloading after the event, so any of your peers who might not be able to attend this, you can give them the link. They can access the information on demand because we think this is critically important as you're finalizing your plans for 2020. I'm going to let each one of the speakers introduce himself. It's going to be absolutely fantastic. I know it'll be very useful. So without any further ado, I'm going to turn it over to Brian from AWS to give our opening strategic overview. So appreciative of your time. Brian, let me turn it over to you now.
Thanks, Ron. I'd like to just start by taking a look at what cloud is, because a lot of us have heard the words cloud probably too many times from every product vendor out there. But for the way I'm going to speak about it, it's about the hyperscale cloud. It's about the larger size, and what makes it different is the not only the aspect of how it covers the globe and some of that, but the difference from what we do on premises is really, I guess, defined why it exists by a story back 15 years ago. There was a retailer 15 years ago that was very advanced looking and thought that a lot of sales would be done online in the future. And so back in the 2004, 2005 timeframe, I hadn't purchased anything online yet. Many of us hadn't. But this company did a big push for Black Friday to get people to buy their toys online. They even offered a free Tickle Me Elmo doll if you spent more than $100. And so it drove a lot of people to their website. And they built out their on-premises data center 10 times bigger than they had ever had before to handle the load. And fortunately and unfortunately for them, they had more than that come to their site to go purchase toys that Christmas. The iPhone wasn't even out at that point, right? That was 2007. So it was a little bit before we were all used to it, but still it overwhelmed their systems. They were down, basically it was a denial of service, but it wasn't an attack. It was that they had too many customers trying to purchase toys. And so this was Toys R Us. And what it showed the whole industry in retail is that unless you ran a model in computers where you over-provisioned your hardware to a point that would probably put you out of business, there's just no way to handle the unknown spikes unless we do something like a cloud where we have thousands and thousands of servers sitting there for you to utilize when you get a spike like that. When, at that time, the Oprah Winfrey Show pitches your product and everybody comes to your site, how do you scale to handle that? And the thing is since these servers are there for anyone to use, when one side has to use it, they grab it and then they return it and someone else can use it. And so that's really the hyperscale cloud is why that's different than traditional on-premises things. And that's great for for people in retail, but there's other reasons why there's a little bit of magic in this type of a design in the cloud. One of those things is availability zones. So what an availability zone is a cluster of data centers. It's one, at least one, if not more than one data center in a region or an area, but these data centers are far enough apart from each other that they've got different power grids that are feeding them power. They're in different floodplains. They're in different disaster areas. The reason that they're in a region that's close enough is because the speed of light has to be fast enough that we can have, sub single-digit millisecond response times. And in the US, it's sub 1 millisecond response times between these data centers. And that lets us do things that our business partners have always asked us for, and we've never been able to offer. So availability zones are really part of this cloud environment that are really unique and helpful. In this design, I'm showing a 3-tier application where, the A section and the B section are actually completely different data centers. But I've got my application going across those from a data sync on the back end with maybe Microsoft SQL or Oracle or Postgres, MySQL. I can synchronize that data and make sure it's committed on both sides before letting the application continue, which is something we traditionally haven't been able to do because across data centers, it would take so much time and latency. It'd be a bad experience for the customer, for the end user, application user, because they'd have to wait for those updates. And so we wouldn't be able to do this type of design across data centers. And then the scale out, there's other aspects here from both security and performance and lowering costs that we can get that we won't go into for today's environment. This is great for fixing those problems like Toys R Us had. But it also comes into play to help enterprises. So if we look at, an enterprise environment, they can hook up to that with a direct connect line or a VPN. They can have a private subnet that's not accessible by the internet. They can further do things in security with the network to give access to the internet and have really good high-speed links that generally we haven't had on premises, not in the redundancy and the high speed. Just as an example, one of our customers, Netflix, on Friday evening, they push out 1/3 of all internet traffic in the United States on Friday night. And that's just one of our thousands of customers. And while they do that, all of our other networking works, right? If I go and purchase something from Amazon.com, that still works the same. Or if I go take a Lyft and order that to go somewhere, which is one of our customers, that works just fine, just like it does in the middle of the day. So that is part of the aspect of why enterprises are coming here is they can also save about 36, 37% on average from running on premises, just in cost of running exactly the same type of environment. And then you can lower it, that cost, and get more agile, including improving the security. Between our networks, and between our servers, everything is firewalled. And so port-based firewalling is in effect here, and most of us didn't do that on premises. So that means if I have 2 servers sitting next to each other and I want them to talk to each other, I still have to put rules between their networks to say, yeah, you can talk, from the IIS web server to the backend SQL server on port 1433, you're allowed to talk there. And the benefit of doing this port-based firewalling is you have to know then what services you have running on your boxes, and you can define that. If someone were to take over that web server and try to do a port scan of the network, they can't get any other information other than, in any replies, because everything's blocked except for what that server is made and allowed to do, right? So there's just at the low network level, we have some security things that very few customers have done on premises. So we can up that level and ability and security. I'm going to look at a couple of the new launches that we just announced this 2 weeks ago, and or that was a week ago only. But I'm going to go through, and I broke it into compute, network, and security, but they're all security focused, brand new features. And so it takes cloud and moves it down that security path from a couple different vantage points. And let's start with compute. So first off, in 2006, when AWS really first launched, we're at a much slower machine. The machines have gotten much faster. You know, the RAM has we got some pretty large boxes, and the network connectivity up to 100 gigabit per second of network connectivity, 128 CPUs. Certainly, there's that ability to scale up. But when we look at that, what about security, right? We've had all these attacks to the physical chips themselves. One of the things we just announced is what's called Nitro Enclaves. Nitro is our hypervisor. It's a version of an open source hypervisor, but we do a lot of the work in ASIC hardware chips that are on a Nitro card that we add to every server. And with the enclaves, what we do is we have a secure isolated storage area that's non-persistent, that administrators don't have access to, that isn't storing to disks, so there's no access to the information that's stored there. So these enclaves are a secure portion area that's on the CPU or on the box, but that root or local system of a Windows box administrator does not have access to. And so these are something that developers can use to have a very secure place to store data while they're working. Their certificates, for example, might go there. Things that can stop common attacks, like in Windows, the pass the hash attack. By grabbing out of memory that certificate, right? This is something that you can't grab unless you have access to it. And code that runs here is signed and guaranteed to be, every time it runs, the signature is rechecked. Another area we've done some work in is building our own processors. And so we are on our second version. We just announced this and are just launching the Graviton 2 processors. They're a 64-bit ARM chip, and the performance has improved quite a bit. They're a lot less expensive, and from a performance, they're rather performant. Certainly, they're not as performant as the highest end Intel chips, but they are a different attack vector as well from the Intel chips. So most of the hackers and the things going on are very well versed in the x86 architecture. And so we see a lot less going on in the ARM space. Not that security by obscurity is the best route, but the types of chip attacks would definitely, they may not exist on this platform. In addition to that, they would have to be altered to actually work, usually from an Intel version, even to an AMD version. And we do have both of those in our environment. But then going to an ARM version, it was going to be different as well. Another thing we've been doing a lot of work on is in the machine learning area. And we're going to talk a lot about different machine learning pieces. So not only what you can build yourself in machine learning, but things and services that we've built to help improve security with machine learning. But at the heart of machine learning is usually it's very expensive to do machine learning. It takes a lot of compute power. And so it's the inference is what it's called as far as the data processing that takes up most of the cost. And so if we look at inference, we can really get some improvements if we go with custom built ASIC chips, chips that actually are built custom to do this type of work. And so if we look at, people, if you do it with a CPU, you have lower performance per watt, but CPUs can do this work. And a lot of people have gone to GPUs, which GPUs can do a lot better. And ASIC chips can do even better. And so what we've just launched is basically an instance type that has 4 custom-built ASIC chips in each instance to do machine learning. And what it does is it lowers the price performance by 40%. It does faster compute for inference. And so it makes it easier, and we leverage this for our machine learning to make these things not only learn faster, but to lower that cost. And so with that, we've launched another thing that is called AWS Neuron. It's basically a toolkit to make it very easy. And the 3 major frameworks in machine learning are TensorFlow, MXNet, and PyTorch. They're all supported, so you can build your own. We use these things to build our environments, and I'll talk about those in a second. But the last thing in compute I wanted to touch was our announcement of Kubernetes on top of Fargate. So we have a managed Kubernetes environment, and managed Kubernetes, not only is it nice to not have to manage and patch and do some of that from your control plane, but in addition to that, being able to run on Fargate lets you do that without owning the instances it runs on. It can run on our farm of servers, which can reduce costs quite a bit. From a security standpoint, the managed services are nice because they're usually misconfigurations are a problem in security. And so when we're doing our managed environment, we're running that with a best practice security framework. We're doing continual audits. We're continually watching for issues. If the way we run our hypervisor control plane, if anyone is to communicate outside of that control plane, we immediately shut that down. So there's some things that are done here that add to that security aspect. And so running managed services is helpful, and running in a Kubernetes Docker area and able to do that without having the instances being paid for by yourself, right, can significantly reduce that cost while giving you that increased security. So that's the compute section. Now, if we look at in the network area, we have things for people to do on premises. If you have certain aspects of compliance that you need to do, if there's a latency issue, if you're running, say it's a beer company and you've got your racks that, your machines that are bottling, you certainly don't want to have to stop producing your beer if the network connection is down. And that latency you can have extremely quick by putting AWS into your data center, and Outpost racks do that. They're basically a computer rack of our environment, able to run a subset of our services on premises and have that data stay on premises if that's needed. The way it works is it integrates just as an availability zone would. So it's considered another availability zone. You can expand your network to cross those. You can sync data between them. If you don't want data to go there, you can keep your data in just that availability zone or that outpost network. And we've got managed services there. We just released and announced RDS, which is managed SQL or managed Postgres running on that. And so it's a fully managed database platform where you don't have to do patching of the OS. You don't have to do patching of the SQL platform, because we do that patching for you, and it can be run on premises. So the way that works, as we showed before, right, you just have your availability zone. It's extended to that availability zone as far as your virtual private network. And then if you wanted to synchronize data between, you can have it 100% run in your corporate data center. It just adds another aspect of how we run our business, and giving the ability for people to meet certain compliance needs that require data to be on premises and not somewhere else. Now in the security space, I'm going to start with just talking about S3 and some of the things that people are building here, and then we'll look at the machine learning services that delve within there. So if we look at S3 is our standard object store. It was our first service to release back in 2006. What it offers is a very low price point of data storage. And one of the lowest, easiest things to do is backup and restore. People use it for. They use it for archive and compliance. In the most expensive version of it in the United States, it's 2.4 cents per gigabyte per month, which is not bad. But when we get to the archive and compliance, our deep storage, that costs as low as $1 per terabyte a month. And so it's very attractive in that we can have all this data that we keep accumulating and store it at a very low price point. The other thing is that when we store it here, it's got 11 nines of durability. And durability is the measure of, am I going to lose that data, right? And so it's synchronized and mirrored across at minimum of three different drives at all times. Depending on the offering, it's across multiple availability zones, which helps keep the access time higher. But the durability of not losing data is the important piece here. And customers use it for home directories, a lot of data lake because when I start to store petabytes of data, it's nice to store it at a lower price point. And then we have a lot of tools that can work against that, not only analyzing it in its space, but then a lot of data analysis you would take and export that data out of S3 and into a more expensive data analysis tool, and then delete it from that data analysis tool once the analysis is done, so that we keep our costs low. So with all of these things we're doing, what we've found, and if you've paid attention to the news, is people have S3 breaches. And the reason they generally do is because customers often configure their S3 access incorrectly. A lot of times it's been open S3 buckets to the world. I went to research to list a few, and as I found hundreds of examples, I decided not to pick on any company in general, and really just say, it's not that S3 isn't secure, it's that customers often don't know how to make sure it's configured correctly. And so there's been a lot of tools released for that. We've released tools in the past that if you have it open to the public, it flags it as public very loudly. By default, it's not public. By default, it's private. But a lot of times, customers go in and they make it public. One of those things is there's a way to set that any authenticated user can access the data. And customers coming from on-premises think, well, geez, I do that on my file share, that any corporate user, if they're authenticated, yeah, they can access this file share. But any authenticated user is not any authenticated corporate user inside AWS, right? It's any user of AWS, which, if I'll use the Coke and Pepsi example, right? If I put, the secret formula for Coke in my S3 bucket and say it can be accessed by any authenticated user, well, when Pepsi logs into their AWS environment, they would be able to access that because they're an authenticated user to AWS at that point. So that is one of the areas where customers have misconfigured their S3 buckets. And so we've done a few different things. The first thing here is using machine learning to analyze S3 access, and then basically let customers know where their policies are. We've got other policies that will force no access to public, and basically try to provide that high level of assurance that these buckets are not open. And the reason they can be open is some people run their websites, and that is their website. S3 is a great website. If you think about some of these companies that offer websites for $50 a year, how do you make money when you offer a website at $50 a year? One of the ways is you use S3 as your underpinnings, where I can put a gigabyte website out there, and it costs me about 2.4 cents a gig a month to host it, and then a little bit more for the network traffic. So for around 3 cents a month, I can offer that gigabyte website. But I can offer it when I run it and offer it to my customers, and I'll add some value in templates, but then I offer it to them for $50 a year. That's a pretty good profit, right? That's probably $49, of profit, or somewhere around there. I didn't do the math correct on that, but you get the idea. So anyways, this analyzer is using the machine learning to tell our customers, and analyze all of their policies and their accounts very quickly. Another thing we just launched is S3 access points. Traditionally you'd have a bucket, and then you access that bucket and you'd set restrictions on who could access that. But what we find is when people do data lakes especially, there's many different teams and many different people and even partners that need access to that data. And so how do we set up that data access? Traditionally, it's been we give all that data to the same bucket name, and then it becomes a little bit more difficult to manage and understand who I'm sharing what with. So what we've done with this is we put different names on that, right? We basically give it an access point, and so I give that access point for the finance team and the rights that the finance team has, whether they can read or write, and what areas they can read or write within that. I give access to the accounting team. And so I can have this bucket completely blocked at the base from anybody but the system that maybe updates it, or anybody. And then I give these unique names, these unique access points, their unique privileges. And so it will make it so that I can give a very prescribed access and keep track of them individually. The way access points work, yep, it's kind of what I've tried to describe there. We segment the different people who are going to access into their unique name. We basically they target their own DNS name, and then that policy applies towards that DNS name of how they access it. Another machine learning tool that we've just released is called the AWS IAM Access Analyzer. And in AWS, we have identity and access management. That's our user store of username, password, one-time password, the security to get in and manage your AWS fabric and give access controls or get access to S3 buckets and all the other services we offer. Once you set your policies, how do you know they're all set correctly? How do you know that whether they just did it by accident or whether they were a malicious employee set your policies and then, moved on, that they set it incorrectly? So the IAM Access Analyzer will go through and look at all of those different rights that have been given to your users and be able to use machine learning to identify which are overly broad permissioned to help find, areas where leaks could occur, to help find areas where you might want to tighten up those permissions or change those permissions. Another machine learning service that we've released is called Amazon Detective. And it's a tool that visualizes your data. It stores your data in a graph database to basically uncover patterns. And it looks at network traffic, it looks at API calls. Like, for example, let's say all of a sudden we're having an area where API calls are starting to fail a lot, or some other access is starting to fail a lot. Well, there's a good chance that problem is happening because someone's trying to break in, right? Something's gone on. Either somebody wrote bad code and that needs to be fixed, or we have a security problem. Another thing, often when people try to access or log in from a Tor exit node, how often is that part of an enterprise's business? Very rare. And so having this tool look for Tor exit nodes that are trying to access our APIs or our network and flag that as most likely malicious activity, those are tools that can be utilized in here. Basically what we do is we turn it on. Amazon Detective will look at the logs. They'll look at VPC flow logs, which are like your packet sniffing traffic, all of your traffic, as well as another service we have called Guard Duty. It looks at all of those things. It does an analysis and makes it easier to find root causes of issues, breaches, and hopefully even before the breach happens. And lastly, what I wanted to talk about is just a higher end tool that we've introduced last week called Fraud Detector. This is a tool that makes it easy to detect online fraud, whether it's user account creations. So I don't know if you're aware, but often bad actors go and create new Google accounts or new AWS accounts or new Azure accounts or et cetera, insert Facebook and others. But there are trends in how they build those things that can be detected. Even more importantly is when someone is doing an online purchase. There's trends of, when stolen credit cards are used or when they're using something that is fraudulent. There are trends that develop. And what this tool does is it builds a pattern that we can detect fraud. And so a general example is if a customer is purchasing something, the application, the website that they're purchasing from will go and check against this service to then return back whether or not it has a confidence that this is a valid user. Our parent company uses this system. For example, I was purchasing something last week, and usually I can just do the one-click purchase and buy, but I was in Las Vegas last week at reInvent. And so when I went to purchase this little, it was an access point, and I wanted it shipped. It was a travel access point, a travel router. I wanted it shipped to my hotel, and therefore my score became, well, something's not right here, right? It's not going to a known address where Brian lives. It's, still his information, but it dropped my score to a point where they said, we want you to log in now, because with multi-factor authentication, because where we trusted that app for those purchases before, now with a different address, we don't. And so it's possible fraud. And so it made me authenticate, and then it accepted that order. These types of tools are very easy to build now with this fraud detector, that any customer can build that into their applications. So in summary, basically these different tools, they help lower costs, they help improve security, they help improve agility, and it's all through this infrastructure modernization. Typically, our beginning customers, they just lift and shift into our environment. And so they can get some security if they improve the way they do things from a network level security. But then as you add more services, like in Windows, it often wasn't done that you would basically use a center point for your logging. But the standard practice in AWS is to use a CloudWatch and CloudTrail to centralize those logs. CloudWatch to instantly respond to some type of problem. Cloud Log to be able to have that historical data to go back and look. And we have best practices set up on how, the administrators can't go affect those logs. They immediately, as they're created, get transferred from the servers into the service, and then only the security group would have rights to that service. So therefore, a bad actor isn't able to log in, escalate to admin, and then delete their tracks. And so as we go down that list down to a truly optimized cloud infrastructure, where we move to serverless, where we move to managed servers, and we can improve not only security but agility and lower cost at the same time. So that's the idea behind these different services, and hopefully that is helpful and beneficial to you guys. Now it's time for me to hand it on over to Raphael from TrendMicro, and thank you, and we'll hand it on over to you, Raphael.
Thank you so much, Brian. Can you all hear me well? Assume that is yes.
Loud and clear to me.
Awesome, thank you. Thank you so much for a ton of great information. I was there myself at reInvent last week as well. And but there's so many new announcements, new stuff happening all the time. It's always nice to see a summary of everything. So I really appreciate that. And my name is Raphael Bottino. I'm a solutions architect here at TrendMicro. For those that don't know TrendMicro, we are a cybersecurity company. We've been doing that for the past 30 years. And recently with the cloud, right? Everybody's talking about the cloud, and we become great partners with AWS. So hopefully I'm going to show some information here that might be contribute with what Brian just told us on the past 30 minutes. Okay, so all right, okay, so it's working now. So something that and you can see on every single new piece of technology that Brian just showed us, we are always talking about what is being faster, right? I want to process all this data faster. I want to make this data accessible on S3 because it's faster, lower latency, right? And what faster means to us, to every single one of you, it might depend, right? If you're dealing with data, you want to be able to access your data faster. If you're dealing with computing, you want to compute your data faster. But we need to think as a business, right? And to the business, faster means being able to deliver to the market faster, to be able to listen to their customer faster and then make the changes as much as they need. It means removing obstacles, right? Because if there are anything in the way between you and be able to delivering what your customer is needing, you need to find the fastest path to that destination, right? Or de-risking new capabilities. And if you think about it, and we've even though we never mentioned the word DevOps during this conversation, everybody has been talking about DevOps. And that's exactly the key differentiator between customers now, because anyone can create their own Uber app, right? But Uber can deliver faster because they got to the market faster, right? So that's exactly the key differentiation between customers now, being able to deliver what your customers need as fast as possible, right? There is a problem though, especially if you guys are listening to me here, if you have security background, you're probably going to agree with me here. If you're a developer, you might understand that side as well. Any company that you go to, you can see an army of developers, right? And then there's the operations team and DevOps. But even with DevOps, there are way less people dealing with this infrastructure side. Doesn't matter if it's a physical infrastructure or as a code on AWS, we still have way less people on that side. When you look to security, however, that is barely a person for every 30 people, right? And that's really challenging because the business is telling us to move faster. It's probably, and clearly you can see that it's faster to deliver new features with an army of developers writing those. But of course, security should be a concern, and we have not even a person for every, I don't know how many developers on a usual team, right? And the problem is that whoever slows this flow to get to the customer and listen to the customer as fast as possible, it's an enemy, right? And we don't want security to be an enemy. But still, security is important. That's why actually during reInvent we announced AWSTrendMicroWebinarDec2019 1. It's our security platform for cloud builders, right? We want to simplify security to the cloud. That's it. Simplify how. It's a unified platform, single sign-on. You just need to learn one tool instead of different tools, one place for visibility, integration with AWS services. So yes, one place for visibility, but if you want to have all that information on your AWS Security Hub as well, you can push that information there. So if you need to if you're on the procurement team, it's just one instead of different vendors, a standard documentation and platform, right? And what exactly is this platform? And that's exactly what I'm going to talk about now. There are 6 different modules, as we can see. There is every single piece here is a different module. Some of them I'm going to talk really fast because unfortunately we have just around 20 minutes. Some of them I'm going to talk a little bit more, especially because we have this agreement on talking about a little bit more about containers and Kubernetes, right? Because that's something that is really important to everybody here, I'm sure. So I'll start with network security. Some of you might have heard about tipping point before. Tipping point is our network physical box IPS that we brought to the cloud. So really simple. It's a simple deployment model. We leverage AWS Transit Gateway. Depending on how much throughput you need, we're going to leverage FPGA instances. So basically, you can virtual patch against any vulnerability on the fly. So if you have your workload here, and by workload, it could be, for instance, your EKS nodes running your containers. We can see the communication between the world in your containers and see if there is an attempt to exploit a vulnerability on those, right? conformity. I love that piece, and it goes also a little bit to what Brian was talking to us about before. Excuse me. The problem is that whenever we see a big leak that happened and it was running on something like AWS, 99%, that's what Gartner says. I would probably guess that it's probably higher than that, but Gartner says that it's the customer's fault, right? And that's mainly because of misconfiguration of the services, like the public S3 bucket, right? And through cloud security posture management, Gartner also says that through 2024, companies are going to reduce cloud-related security incidents by 80%, okay? So how can we help with that? So we have this conformity piece that connects your AWS account, your AWS accounts across regions, and it's a cross account road that we need access to. Super simple to deploy. Takes like officially 15 minutes, honestly less than 5. We can check for compliance, especially against the AWS well-architected framework, a great tool to have to hold to, but also PCI, HIPAA, NIST, etc. Right? And what is cool is that any changes that happens that violate any of those compliances, you can be notified right away and even autocorrect, self-remediate the issue. So if somebody creates a new public S3 bucket, we can detect that and run a lamp that you go back there and close that bucket, right? If that's something that you want to do. Also super cool is that even before creating all this stuff on AWS, if you're declaring then as an infrastructure as code in a CloudFormation template, we can scan the CloudFormation template looking for any problems there before processing that template and creating new resources on your AWS account. And because we're talking a lot about containers and Kubernetes here, I brought some specific rules on EKS. So just a really small sample on how we are handling your configuration or misconfiguration of AWS. Okay, so if you change your security groups on EKS to receive communication on a port other than 443 on TCP, well, you might want to do that. You might, but that's probably something that you need to take a look into, right? So that's why we have this kind of rules, always following the well-architected framework. Then we have the file storage security. So I know that's not thing related to containers and Kubernetes directly, but think that your applications are probably leveraging S3 as their storage, right? So it's important to know that anything that you're processing to or from your bucket is a clean file that is not infected with malware, right? Because it could infect your EC2 instance that is processing that information. Or even worse, you could be sending a malware infected file to your customers, right? So that's why we have this service. So for any object, any file in your S3 bucket, we can scan and make sure that it's a clean file, right? If it isn't, you can do whatever you want with that information because we're just triggering SNS notification, right? So let's say that you're working on a bank and a customer just submit a file to you and you detect that the file is actually infected. You can go back to your customer and say, hey, we didn't accept that file because it was infected, and we do recommend you to do a full scan malware search on your computer, and also trigger something else on your backend, maybe to double check the last transactions for that customer because maybe their computer were compromised and therefore their credentials, right? It's really up to you what you do with that information. That's pretty cool as well. So this piece has a lot to do with new applications, right? That's the application security piece. Maybe you've heard about Immunio before. It's a company that we acquired over 2 years ago now. And we've been working on adapting that to the TrendMicro platform. And we're releasing this beginning of next year, January. And the idea is here, if you're running serverless, right? Everybody's moving to serverless as much as they can. Because of course, offloading all this responsibility around managing the infrastructure, it's a great idea. Whenever I have my own projects here, I offload as much as I can to AWS, and then I use Lambda, right? I use S3. So application security allows you to protect your application that is running on a serverless environment, right? Because usually you need to install an agent on a server or something on the network, and maybe there's something that is installed on your network on premises doesn't work on AWS. So the idea here is that with minimal impact on performance and really simple to do, just 2 lines of code, you can secure your application, whatever it's running, right? So as a developer, you go there, you do import our library, that's it. If you're running a monolithic application or your data center or a bunch of microservices in Lambda, you are protecting the application the same way, right? And what is cool is that it's not a WAF, it's a REST, a runtime application of self-protection. So it sits inside of the application. The big difference is if you have a WAF and there is somebody from the outside trying to attack your application, the WAF detects and block, that's awesome, right? Great work, kudos WAF. But then you have a lot of information to analyze that you are not sure that that attempt would actually affect your application. Whenever inside the application with this kind of technology, whenever we detect anything, that means that your application allowed that communication to go through. That means that if it wasn't for application security, it would be a problem. It would be a compromise of your application. So whatever we're detecting, it's actually an actual vulnerability, something that you need to fix. So we are giving you good information to work with. We even give you the stack. So the memory stack. So if something happens, you can see exactly what was happening when that happened. You can see exactly which line of code that happened. So think of Dynatrace or something like that, any kind of APM, but for security. It's pretty cool. And for Lambda, we can work as a Lambda layer. So basically all you need to do is to add our layer to it, and it's super simple to start protecting your functions, right? Also, if you're running something like Fargate, right? You don't have the capability of protecting the host underneath it. Well, you can protect your container running there with a technology like this one, right? Cool. Then we have the container image security. Okay, so it's basically scanning your images before they become containers in production. And AWS actually has something pretty cool built into ECR where you can detect any vulnerabilities on images that you push there. But we do a little bit more. We go a step beyond. We are not just looking for vulnerabilities when you push the image, but also for malware, secrets and IOC compliance. So let's say that a developer push an image, a container image with a secret key on it, a pen file, or that developer laptop was compromised and now it's pushing malware to inside the image, right? We can easily detect that and work with that information, right? And you can build that to your pipeline as well through APIs. So basically, you can have it here between building and pushing to your registry. So before pushing an image to a registry, we can make the decision on, is that image good enough to go to the registry or not? So you don't need to push to find out if that is good or bad. You can detect even before pushing to the registry. On top of that, we can do a constant scanning of the registry, because maybe something that went to the registry today, we find that it's good, but then a new vulnerability is disclosed, right? So we can go back there every now and then, we're scanning again, and we can find that information on maybe an image that is sitting here on the registry that was good until yesterday, now it's not, right? And the last piece here on the Cloud One platform is the workload security. If you're a TrendMicro customer, if you talked to us before, you probably know this space as deep security, okay? So it's our work time a solution it's installed as an agent on a host, okay? And we've been dealing with this technology for the past 10 years. But it has been evolving every single day to become a technology that also helps you secure not just your host, but also your platform, such as Kubernetes and your Docker or any other container engine, and your containers running on top of it. And which is pretty cool also is that starting a year ago or so, you can also do container traffic inspection. So let's say you have your workload running on top of EKS nodes, and then a container is compromised, right? And you don't have any clue about it. If an attacker tries to attack other containers from that one, it never reaches the network. So if you have something in the network to inspect traffic, it wouldn't be detected. And even worse, it gets it's really hard to see this communication. But sitting at the OS level, we are actually able to see the traffic between two containers and detect any possible attempt to exploit different containers coming from another, right, in the same host. So basically, we see the east-west traffic between containers. And also, like I said before, we are working, even though we are on the OS, we are protecting the full stack here. We're protecting the OS, the Kubernetes, your container runtime, maybe Docker, maybe something else, and your containers as well. And why is that critical? Let's see an example here. We have different Kubernetes and Docker monitoring rules here. For instance, if anybody makes a change to, makes a change to a configuration file on Kubernetes, right? That's something critical. That's something critical that we need to know right away. Or if they make any changes to the Docker conf file, that's something critical as well. So they are not attacking your containers, but they are attacking the platform itself, and they are opening the gates for the attacker to do whatever they want, right? So we are always monitoring those critical files, looking for any changes and alerting right away so we can act on that information. Another great example is that actually was a CVE this year, the run C vulnerability. For those that run containers in production, you probably heard about this one. Basically, a compromised container was able to get outside of this jail, right? And communicate with the host and change the run C binary. So basically, it's allowing an attacker to modify how that host would run the next containers. It was giving full access basically to the attacker. And with this kind of with this solution that I'm mentioning here, we were, even before we knew about the vulnerability, we were actually protecting our customers because we were able to see that a binary was changed, and you could either alert your team or just simply block it from running again. So excuse me, this modified version, right? And these past two solutions that I mentioned can work really well together as well. So we have the the container image scanning here, and also the runtime on your nodes. It doesn't matter if it's an EC2 instance running Kubernetes or your EKS node, we can protect both. And for Kubernetes environments, we can actually deploy, and I know whenever we talk agent, people tend to not like that word, but we can deploy our technology, the agent, as a daemon set. So you don't need to SSH into your instance or do a script on the user data script to install it. You can just install the agent as much as you do install every other application. And working together, we have a lot of capabilities that is summarized here. I won't go over all of them because we don't have much time left, but I want to show you this. Because we have visibility on the image scanning and also at runtime, you don't need to not push your container to production because there is a vulnerability to it. Actually, because we know the vulnerability, we can send the workload protection to shield that vulnerability. So you can send that image even though it's not 100% safe. There is a known vulnerability to it. We can shield that vulnerability at real time while you work on fixing, upgrading your libraries to make that image 100% free of known vulnerabilities, right? So like I said, it's all about moving faster. This kind of visibility allows you to move faster. You don't need to hold yourself until you fix, because you can use this workload security piece to shield the vulnerability while you work on fixing the problem, right? And the same solution, it also works across your environments, not just cloud and containers, but even virtual servers and data centers, even on Windows, Oracle, even IBM, AIX, HPUX, right? So a lot of different flavors here that we can protect with this solution, okay? And the things that like I said on the beginning, we are partners, really good partners of AWS. So we are optimized for AWS. Simple billing, we can integrate with AWS services. So any detection can be a SNS trigger. We have a lot of quick starts guide that you can use, CloudFormation templates. So yeah, super simple to start with our technology on AWS. And what is it's good to know is that we're ranked #1, and that just came out last month for hybrid cloud workload security according to IDC. So 35% of the market on hybrid cloud space are protecting their servers with AWS, with TrendMicro, including on AWS. So it's good to know that it's a technology that is trusted by other peers as well. If you want to know more, you can always reach to us through trendmicro.com/AWS, or you can email me at Raphael_Bottino@trendmicro.com. I really hope that was helpful to you. And yeah, thank you so much for the space. And Brian, thank you so much for the great information.
This is Ron Gerber now. And I think those were two great presentations. When I go around for a live AngelBeat seminars, we know everyone's very concerned about their cloud strategies. Everyone's concerned about how they protect this information. I think Brian did a great job of articulating all these great innovations that AWS is doing around Fargate and its new chipsets and ARM-based processing that's optimized for cloud applications, showing why cloud applications are going so rapidly. But at the same time, that new computing architecture does create new threat vectors. It's very important that everyone understands the shared security responsibility model. We have a three-pronged strategy of understanding what AWS does. Brian did a great job of that. Understanding what you need to do as the end user and focusing very much on securing your data. And the third major leg is working with companies like TrendMicro to fill in the gaps with all of their great functionality. It's very much a defense in-depth strategy. One of the advantages in working with companies like Trend Micro is that it does give you the flexibility for a common management console, because people still obviously do a great amount of computing and applications on-prem, but you want to have a common security tool to protect cloud-based applications, on-prem applications, your local area network, your wide area network. So there's lots of great expertise available. As we finish up now, I know there are many questions. Anyone can respond back to me, rgerber@angelbeat.com, and I will make sure that all of the questions are answered directly. If you go to angelbeat.com under social media and then slides, I will make all of the 2 slide decks available. You'll also get a link, and I'll also post this on the AngelBeat site. We'll also make sure we send the information to Trend Micro and AWS. So the on-demand viewing of this great webinar can be made available for all your peers and for future viewing. I was really excited to see Trevor Chandler, a loyal AngelBeat attendee, saying he wanted to replay this webinar multiple times, and that was very satisfying because we hope this content will be of great use for you as you are planning out 2020. I'm going to now stop the webinar and stop recording. Want to thank everyone very much for your time. Wish you the best during the holiday season, and I very much look forward to seeing you at a live event or in this virtual community. Thank you all very much, and especially thanks to Brian and Raphael for delivering such great content. Thank you very much. Bye-bye now.
Thank you, Ron. Thank you, Brian. Thank you, everybody. It was a great time, and I hope to hear from you. Bye-bye.